Thank you so much for being here via Zoom and YouTube. This is joint work with Daria, Bottan, Douglas McKee, Stephanie Thomas, and Jennifer Wissink at Cornell University and Irene Foster at George Washington University. And so let's talk about math skills because they're critical for success in economics courses. If you think about our introductory courses, they require students to have a good grasp of basic arithmetic, algebra, also be able to work with graphs. And if you think about intermediate courses, we also throw in calculus in the mix, whether you're looking at macro or micro. On the kind of side of the instructor, however, we actually often don't have the accurate picture of what our students' math skill distribution looks like when they come into our class, where the holes in the knowledge are. At the same time, probably the students are also not as aware where they may have some shortcomings. So sort of curse of knowledge on both sides. And if we had an accurate picture of our students' math skills, let's say we have a means to do so, what could we do with it? And actually, why should we be doing this? General idea is actually, if you think about it, that when students lack these math skills, they're probably not as successful in our courses. They're probably dropping out. They're potentially not achieving what they could otherwise with some extra math training. And the other part, kind of tying it to the last session, is students who also get hit in this situation, if you look at statistics, minority students and potentially first-generation students, because there's some uneven level of preparation comparatively. If you look at the top quartile of the distribution in the class versus the lowest quartile. So what could we do with it? So Irene Foster actually has been using an in-house math assessment at George Washington University to direct students into a course aimed at developing their math skills to a level where they can actually succeed in introductory economics and maybe proceed further on. Also, thinking of kind of getting a big picture, in 2018, Doug McKee and I at Cornell developed a mathematics assessment for the intermediate microeconomics course. So thinking about calculus, algebra, graphs in that context. So it was very logical then we met in 2019 at C3. We actually talked and joined forces to develop 2 new multiple choice assessments, which can be administered as low stakes assessments. And we call them MESA Foundations, so which covers arithmetic, graphs, and algebra. As you can guess, this is very applicable for introductory courses. And MESA Intermediate, which is aimed at algebra, graphs, and sort of calculus. Meaning we have integration, multivariate calculus, etc. And MESA stands for Mathematics for Economics Skills Assessment. And these assessments, when we were developing them, we were following the rigorous procedures described in the paper by Wendy Adams and Carl Wyman. So this means that we go from learning goals to building questions. We include faculty feedback from our institutions and outside of our institutions, and we actually conduct think-aloud interviews with students to kind of figure out what their misconceptions are and where they go wrong. What do these assessments look like when we take it to data, to take it into the classroom? So this is data from Cornell for the introductory course of introductory microeconomics and intermediate microeconomics. So the MESA Foundations, if you look at this, it has 28 multiple choice questions. 7 of them are on foundational arithmetic. So think of unit conversions, percentages, translating word problems into mathematics. 9 are on reading and using graphs, anywhere from solving equations using math to inequalities, kind of looking through calculating areas of regions on a graph. And 12 questions are on algebra. And this is something which is really important if you think of your supply-demand models. We can think of solving equations, systems of equations, and working with functions in general. Then we updated, sort of moving on to the next level, to the MESA Intermediate. We added questions on calculus. So there's 11 questions on derivatives and basic integration. But at the same time, we removed the arithmetic questions. And the data you're seeing here, for the talk and for what we're doing, really served for Cornell as training data, if you will. We use this to determine the best methods for identifying students, which we would call students at risk. And from that perspective, I mean, we are looking at sort of different categories what could be considered at risk. So why is this important? Why this thing, kind of what might happen? In a typical class, you do not know who the students in trouble are until your first midterm exam. And it might be too late for providing effective support. But if you do administer an assessment as a low stakes, no stress assessment for the students at the start of a semester, we as instructors have two sort of generally categories of opportunities. First one is identifying students with a higher likelihood of failing, dropping out, or underperforming due to lacking math skills. And we can conduct some form of intervention, and we'll offer some ideas at the end of this presentation. We also can identify and address class-wide misconceptions as a part of the start of a term math review or TA sessions, whichever way you want to handle this. But this is kind of because the assessment is tied to learning goals. You can see, oh, people are having trouble with, for example, integration. We can do a little bit of review on that. Or maybe people are having trouble with the chain rule. We can do a review on that. So for what follows, as I said, the data which comes from classes for Cornell, and there are two sections of introductory microeconomics which were taught in fall of 2019, two terms of intermediate microeconomics, it's spring 2019 and fall 2019. We observe MESA scores appropriate for the class, so the foundations for introductory course and the intermediate for the intermediate course. We gender, underrepresented minority status, and so we generally think about, in sort of our context, the underrepresented minority stands for Black, Hispanic students, also Native students for American backgrounds. Sort of a year in college, course letter grades, and first-generation student status and self-reported GPA for intermediate microeconomics. We are currently piloting MESA Foundations and MESA Intermediate at external sites. And if you're interested in participating in our pilot or just using the assessments, you can contact us at econ-assessments@cornell.edu. So what's the goal of what we are doing? First, we identify half of the students who will actually underperform. Keep in mind, this is a fairly arbitrary statement, right? The half part. It really depends on the resources and who you want to treat, right? You can think if you have resources to treat all the students who would actually, or say 3/4 of students who actually underperform, you will be looking at that. But it's counterbalanced by the second goal. Because again, we have limited resources, we want to minimize the number of false positives. And I'll clarify what I mean by that. So what I'll be focusing in the next few slides is that sort of what I would call a low grade. It's a letter grade in the lowest quartile. And in this courses at Cornell, that would be B- and lower. It would be different for your institution potentially. And then what the two statistics we're looking at is the TPR, the true positive rate. So we're looking at a fraction of students who will receive a low grade and score below the threshold, and false positive rate. So fraction of students who do not receive a low grade but score below the threshold. And so we're offering a few ways to try to identify the students who fall in this category based on from assessments or based on a more sophisticated model. So if we look at simple thresholds, the grade in the lowest quartile, and this is just administer MESA, look at the results and say, all right, we will have the blue line representing the true positive rate and the red line representing the false positive rate. And then we can say, well, figure out a threshold, for example, for introductory course at 72, at which we'll have close to half of our students who are actually underperforming with a false rate of, in this case, approximately 20%. It's better for intermediate micro for this threshold purpose. Of course, we don't need to stop at simple thresholds, right? We can actually run a probit model, including more of these variables. Interestingly enough, the probits in this case don't perform much better. The graphs change direction. We're now looking at predicted probabilities, and we're figuring out what would be your predicted probability of receiving a low grade, and we go work with thresholds from there. We went even further because we actually tried, and we are working with some of statistical learning models, think about lasso models, etc. And at the moment, the ones we looked at have very similar results to what we have seen. But it will be different. It potentially will be different for your class. What do you do when you actually have this data? So there are multiple options of what can you do once you know who the students at risk are. You can start very kind of from low to high level interventions, so you can direct identified students to self-directed review. So you know which learning goals they performed poorly on, and you can actually have a more customized review using online systems. Depending on the class size, you of course can set up appointments of TAs or the course instructor. But that would depend in a 500 people class that might be problematic. And then there's the sort of more, I'd say, intense route. So you can develop or have, if your institution has a supplemental course that teaches both foundational mathematics for economics and study skills, you can advise the students at risk you've identified via email, for example, to enroll in this course with optional enrollment. And this is the Cornell route. On the other hand, as I mentioned, Irene's work, you can develop a principles of mathematics for economic course like George Washington University did, and you strongly recommend the students to take course before they enroll in introductory economics course. And obviously, Irene would probably be able to tell you much more about this. And so, first of all, thank you for your attention. I know it's a little bit very information packed. I appreciate you bearing with me. And if you have any questions or are interested in piloting our assessments, and this doesn't just relate to mathematics, you can contact us at econ-assessments@cornell.edu, and you can learn more about assessments and what we do at Cornell at the Active Learning Initiative, including this MESA assessment for mathematics for economic skills assessment at the following address. Thank you so much.